Dear friends and students, in most of the cases when we have a complicated electrical circuit, and if the electrical circuit has to be simplified, wherein you have to find the equivalent impedance or the equivalent resistance, in most of the cases you may get a star connection or a delta connection here. So here I have a star connection where Z1, Z2, Z3 are impedances. So they can be resistances or capacitances, or you can have inductors connected in this way in the form of a star, or if it is connected like this, it is referred to as a delta connection. Now to find the equivalent impedance or the equivalent resistance, sometimes you may have to convert a star to a delta or delta to a star so that the entire circuit can be simplified and you can find the equivalent impedance or the equivalent resistance. So we will take a few problems wherein you may have to convert star delta or perform delta star conversion to get the equivalent impedance or equivalent resistance. So let us first see the formula required for star delta conversion. Now if I have to convert a star network to delta, that means let me consider a delta network. So this is a delta network. So either I consider a resistance or either I consider an impedance. So let me consider an impedance here. So let this impedance be ZA and let this be ZC and let this be ZB. Alright, so if I have to convert a star to delta, I need to find ZA, ZB and ZC. So what is ZA? So in all the three cases the numerator remains the same. So what is the numerator? You have to multiply two impedances at a time, that is Z1, Z2, add it with Z2, Z3, add it with Z3, Z1, and here since I need to find ZA, right, I have to divide the numerator by the impedance opposite to ZA, which is Z3. Very simple. So if I have to find ZB, the numerator remains the same, right? So the numerator is Z1, Z2 plus Z2, Z3 plus Z3, Z1, and remember ZB opposite to ZB is Z1 divided by Z1 impedance. Now similarly, if I have to find ZC, again the numerator remains the same, Z1, Z2 plus Z2, Z3 plus Z3, Z1, and the impedance opposite to ZC is Z2. So it's very simple here. So in order to find the impedance in the delta network, the numerator being the same, wherein you need to take the sum of the product of two impedances divided by the impedance which occurs exactly opposite to the impedance which you have to find in the delta network. Now for delta star conversion, what is the formula? So let me draw the star network which I have to find. So this is the star network. So you have Z1, Z2 and Z3. So here we need to convert the delta network to a star network. So here in delta to star, let's say I need to find Z1. Now in a delta to star network, the denominator remains the same. Now what is the denominator? The denominator is nothing but the sum of all the three impedances, ZA plus ZB plus ZC. To find Z1, remember I have to multiply the two impedances which are on the either sides of Z1, that is ZA into ZC. On either side of Z1 you have ZA and ZC. Similarly to find Z2, remember the denominator remains the same, which is the sum of all the three impedances in the delta network. So Z2, on either side of Z2 you have ZA, ZB. So ZA into ZB. Now what is Z3? To find Z3, again multiply the impedances on either sides of Z3, which is ZB into ZC, divided by the sum of resistances. Right? So these are the formulas you have to remember. Very easy, isn't it? So whether you have to convert star to delta or you need to convert delta to star, these are the formulas which you have to use. So let's take a few examples wherein we may be required to perform this conversion, that is delta to star or star to delta, to find the equivalent resistance. So we'll take a few problems. So let's consider a problem where we have to find the equivalent resistance between X and Y. Now observe that these two resistances are in series, 10 and 10. So the equivalent resistance here is 10 plus 10, which is 20 ohm. Alright, so now here observe A, B and C, there are three resistors, and if you observe that these three resistors are nothing but they are in the form of delta. So I can convert this delta to a star so that I will be able to simplify and get the final equivalent resistance. So let me write here. So you have A, B, and then you have C. The resistors are given, which is 10, 30 and 20. Right? So observe that this is a delta network. I have to convert delta to star. So I have the three resistors R1, R2 and R3. Right? So delta to star. What is the conversion? I've just written the formula here. For delta to star, here you have resistors. To find R1, multiply the resistors on either sides of R1 divided by the sum of all the three resistors. Right? So therefore, what is R1? Multiply 30 into 10 is 300 divided by the sum 30 plus 20 plus 10, which is 60. So the denominator remains the same, isn't it? Right? So 65s are 300. So therefore R1 is 5 ohm. Similarly, what is R2? R2 is, again, denominator is 60. R2 is 10 into 20. So 200. So 0, 0 gets cancelled here. 2 10s are 2 3s are. So 10 by 3 is 3.33 ohms. So R2 is 3.33 ohm. And what is R3? R3 is, denominator remains the same, which is 60. 30 into 20. So 30 into 20. So 0, 0 gets cancelled. 2 3s are, 3 10s are, so it is 10 ohm. So R1 is 5, R2 is 3.33 and R3 is 10 ohms. So now let me replace this delta network by the star network with resistances R1, R2 and R3 as we have calculated. So now observe, you have ABC. So the entire delta network is now replaced by the star. So I have R1. R1 is 5 ohm. And then you have R2, which is 3.33. So this is 3.33 ohm. And then you have another one, which is R3, which is 10 ohm. Right? Now these two resistances are definitely in series. So we have found out that it's 20. So I can replace these two resistances by a single one, which is 20. So this is 20 ohm. So the moment we convert a delta to a star, what do we observe? We observe that these two resistors are in series, right? So you get 7 plus 5, which is 22 ohm. These two resistors are in series, which is 7.33 ohms. And these two resistors also are in series, so you get 18 ohm. So I can replace all of them by these three resistors, right? So when I add the resistances, so you had 17 plus 5, so we got 22 ohms, and then we had 18 ohms, and then we had 3.33 plus 4, which was 7.33 ohms, and then there was 12 ohms and we had 20 ohms here, and this is Y. So again observe that these two resistances can be added. So when I add these two, 7.33 plus 12, you get 19.33. So this can be replaced by 19.33. So replace these two resistance by their series. So you get 19.33. So now if you observe that this is a star network and I have to convert this star to delta to find the equivalent resistance between the two terminals X and Y. So let this point be D, E, F and G. So let this resistance be R4, and then I have R5, and then I have R6. So this is a star to delta conversion. So how do you convert star to delta? The formula has been given here. So here in this case, the numerator remains the same. So star to delta to find R4. So observe that the resistors have to be multiplied. 22 into 19.3 plus 19.33 into 18 plus 18 into 22 divided by, now to find R4 I have to divide the numerator by the resistance opposite to R4, which is 18. So divided by 18. So the numerator remains the same. So you get the value of the numerator as 1169.2 divided by 18. So the value is 64.95 ohms. Next, what is R5? The numerator remains the same, 1169.2. So now observe R5. To find R5, divided by 19.33. And if we calculate, we get a value equal to 60.48 ohm. And to find R6, it is 1169.2 divided by 22. So it's going to be divided by 22. So we get the value as 53.15 ohm. So observe, I'm going to now eliminate this star network, the delta network, and replace it by, I'm going to replace the star network by the delta network. So what is R4? R4 is 64.95 ohm. R5 is 60.48 ohm. And then R6 is 53.15 ohm. So observe, you have X and then you have R4, which is 64.95. From the same terminal, say D or X, you have 20. So this 20 is between D and G, and R5 is also between D and G. So these two resistors are in parallel. So it is 60.48 ohm. Right? So this is G. So D and X are the same point. And here you have F. All right. So between F and G, I have 53.15. And on the other hand, I have 20 here. So the other hand, I have 20. So observe that F and Y are the same point, right? F and Y, they both are the same point, isn't it? So they are connected by a short. So these two resistors are in parallel, these two are in parallel. So how do you find the parallel resistance here? We know that product of the two resistances divided by the sum. So to find the parallel, you have 20 into 60.48 divided by 20 plus 60.48. Similarly here, to find the parallel resistance, it's going to be 20 into 53.15 divided by 20 plus 53.15. So here I find the value as 15.03 ohm. and here the parallel value is 14.53. So now let me replace the circuit, and then I have the equivalent resistance, which is 15.032 ohm, and then I have another resistance which is 14.53 ohm, right? And then this is Y. So observe that these two resistors are in series, so you need to add them. So if I add 15.032 plus 14.53, I get the value as 29.56 ohm. So now let me rewrite the circuit. So this is X, you have 64.95 ohm. This is Y, and then between X and Y there is the resistance, which is 29.56 ohm. Now these two are in parallel. So what is the parallel resistance? 64.95 into 29.56 divided by 64.95 plus 29.56. So if you calculate, you get the value as 20.315 ohm. So this is between X and Y. So the equivalent resistance between X and Y is 20.315 ohm, right? So you observe that we had a huge circuit, and in order to convert the huge circuit, to simplify it and find the equivalent resistance between X and Y, we had to perform star to delta conversion and also delta to star conversion, and finally we got the answer, the equivalent resistance between X and Y. So we'll take another example and we shall use the same formula to find the equivalent resistance. So here there is another network, another resistive network here, and we need to find the equivalent resistance between A and B. So find RAB is the question. So how do we do that? So we have to observe if there are any star or delta networks. Now if you observe that there is a star network, and this star network can be converted to a delta network. So I have a delta network here. So let me call this as R1, R2 and R3, right? So you have 6 ohm, 8, so this is 6 and this is 8, and then you have 10 ohm, and between these two you have R1. So this is a star network, so this is R1, this is R2 and this is R3. So how do I convert a star to delta? So we know that conversion of star to delta is by using this formula. So the numerator remains the same. So what is R1? R1 is multiply 6 into 8 plus 8 into 10 plus 10 into 6 divided by the value opposite to R1, which is 10. So what is the numerator? The value of the numerator is 188. So 188 by 10, we get 18.8 ohm. R2, the numerator remains the same, so it is 188 divided by the value which is opposite to R2 is 8. So 188 by 8, we get the value as 23.5. R3 is again 188 divided by the value opposite to R3, which is 6. And if we calculate, we get the value as 31.33. Right? So now replace these three resistors, that is the star network, by the delta network. So you have 18.88 ohm between C and D, and then R2, this is R2, which is 23.5 ohm, and then you have 31.33 ohm. Right? So observe here that these two resistances are in parallel. So these two are in parallel. and these two again are in parallel. So we can find the parallel resistance. So what is the parallel resistance here? The parallel resistance is 23.5 into 15 divided by 23.5 plus 15, and the parallel resistance here is 20 into 31.33 divided by 20 plus 31.33, right? So what is the answer? So you get the value as 9.155 ohm, and here the value as 12.21 ohm. So now let me replace these two resistors by their parallel values. So we have 9.155 ohm, and here the resistance is 12.21 ohm. Now to find the equivalent resistance between A and B, I have to convert the delta network to a star network. So you have a delta network here and you also have a delta network here. So one of them can be converted to a star network. So let me convert this delta network to a star network. So we have R4, R5, and then you have R6. So the delta network now is converted to a star network. So let me redraw the circuit. You have 25, 30 and 18.8, and then you have R4, R5 and R6, which we got to find. We have to find the values of R4, R5 and R6. Now what is R4? How do we convert a delta to a star? So delta to a star is very easy. Observe here, the denominator is the sum of all the three resistors, and to find R4, it is nothing but the product of these two resistors, which is 25 into 18.88 divided by the sum of all the three resistors. Now the sum of all the three resistors is 73.8. So the value of R4, what we get is 6.369 ohm. Now similarly R5 is product of the two resistors on either sides, 25 into 30 divided by 73.8, right? So therefore R5 is 10.16 ohm. And similarly, what is R6? R6 is multiply these two resistors, 30 into 18.8 divided by 73.8, and the value what we get is 7.642, right? So now this delta network can now be replaced by a star network. So we had R4 here, which was 6.369, and this was R5, which is 10.16 ohm, and then we had R6, which is 7.642 ohm. So observe that 6.36 ohm and 9.15, they are in series. So these are in series, and these two also are in series. So I can add them. So if I add them, you get 15.52 ohm, and here you add them, you get 19.852 ohm, right? So now replace these two resistors by their equivalent resistors, which is nothing but the sum of those two resistors. So here I have 15.52 ohm, and here I have 19.852 ohm. To find the equivalent resistance between A and B, again observe that these two resistors are in parallel. So to find the parallel resistance, it is 15.52 into 19.852 divided by the sum of the two resistors. So if you find the equivalent parallel resistance, you get the value as 8.71. So this can be replaced by one single resistance, which is 8.71. So you have 8.71 ohm. Now observe, to find the equivalent resistance between A and B, we have to add these two. So RAB is the sum of 10.16 plus 8.71. So the value is 18.87 ohm. So this is RAB. So this is the equivalent resistance between the two terminals A and B. So whenever we have to simplify a large circuit, an electric circuit having a series of resistors, capacitors or inductors, many times we have to convert a star to a delta or convert a delta to a star. So here I've taken two examples where we only had resistors, and you observe that in each of the problem we had to do both conversions, conversion of a star to delta and to convert a delta network to a star network to finally get the equivalent resistance, right? So I hope you found the video interesting and useful. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads. And thanks for watching.